Hi Year 12. I'm going to use this video to give you some hints and tips for this week's assignment on vectors. So I'm going to go through each question, give you some pointers, some clues and definitions, and hopefully that's going to give you a bit of a hand. In the meantime, if you've got any other questions about it, then feel free to give me an email and I'll get back to you. So let's go right in, shall we? So question 1. We want to find an exact form, the unit vector in the same direction as A, which is 4i minus 7j. Okay, so I think the main point here is to understand the definition of a unit vector, which we've looked at before, and that's a vector that has length 1. And we've also looked at a method for taking any arbitrary vector like this and doing something to it to produce another vector that has length 1 and is also in the same direction. We've done that before. So I'll give you the picture version of what we're trying to achieve. We've got a vector A, which may or may not be accurate depending on what we've got here. And then we're doing something to it to stretch it or squash it in such a way so that we get this new vector A hat that has length 1. Okay, and that's worth 3 marks if you can do that. And also exact form as well. Okay, so no decimal rounding, please. Okay, question 2. So we've got a triangle OAB, and then OA is called vector A, and OB is called vector B. Maybe you'd want to put that on the picture, maybe not. And then we've got these other points, P, which divides OA into the ratio 3 to 2, and Q, which also divides OB into the ratio 3 to 2. So now for the first part, we've got to show that PQ is parallel to AB. Well, they look it from the picture, but we have to use vectors in order to show that properly. So you'd want to figure out what these vectors are. That's going to be in terms of these vectors A and B, probably. And then to show that they're parallel, remember that that means we have to show that one is a scalar multiple of the other. Okay, that's going to give you a scale factor between the two. For the second part, it's then just going to be using part A to do some kind of ratio work. So given that AB is 10 centimeters long, find the length of PQ, which is shorter. So I would suggest you just use part A to do that. And that's going to be only 1 mark. Okay, moving on. Question 3. Given that the resultant of the vectors A and B, where A is 2pi minus 5j and B is 6i minus 3pj, given that the resultant of these is parallel to the vector A, which is 4 minus 5, we want to find P first of all, and then what this resultant of the vectors A and B is. So, bear in mind again, so resultant means the sum of the vectors, and again, parallel also means scalar multiple. But this time we've got unknowns in our components here. We've got this P here and P here that's going to stop us from identifying the scale factor straight away. But if I give you a quick example, I can hopefully give you a clue as to what to do to figure out P. So let's suppose that you end up with 5i plus, let's call this, let's just call it xj for now, for our unknown x. And then we've also got 15i minus 24j. Okay, let's suppose that these two vectors are parallel. Then there's a quite easy way of figuring out what this x value is because we know there's going to be a scale factor between the two vectors here. So how I'd set this out is I'd say, well, 15 divided by 5, that's looking at the I components. That scale factor there has got to be the same scale factor as minus 24 divided by x. Okay, I know that on this side it's going to be 3, which means that on this side it will be multiplying by 3 as well, but this is a nice way of setting it out in a way that leads to an equation, and I think you'll be able to do that with this example here. Okay, once you've found P, it then just wants the resultant of the vectors, which just means what the sum is. And then, seeing as you know P, you can get that using just numbers. Okay, that's done for question 3. Moving on to number 4, so we've got 2 position vectors, A, which is 4, 7, and B, which has position 10, Q. We want, firstly, the vector AB in terms of Q. So what I'd probably want to do with this is maybe draw a picture so that you can see where everything goes in the plane, and then you can kind of work out what it is you're trying to find there. And again, it's going to be in terms of Q. And then for part B, given further that the modulus of AB is 2 root 13, we want the possible values of Q. Now, what we need to do is we need to write a sum down that represents what's going to work out the length of AB. And that's going to lead to some quadratic equation that involves Q. Okay, and then seeing as you're going to end up with a quadratic equation, that will be the reason why you're going to get 2 possible values of Q. And I want to see all the reasoning in your working, please. Okay, moving on to question 5. It's another triangle question. So you've got the triangle ABC, and it looks like a question that we've done recently in a couple of lessons. So we've got the vector AB minus 3, 6. We've got the vector AC, 10 minus 2. I want the size of angle BAC, which is the one at the letter A, in degrees to 1 decimal place. Make sure you've got both of those things in your answer, please. So I'm not going to give too much away here because we've done plenty of examples, but the main thing to do is to be able to find side lengths. Okay, all 3 if possible, because that's the information that you're going to be able to need to get some angles going. Then for part B, for the area, the exact value of the area of the triangle ABC. So this means no rounding. So if you see a value like root 2, for example, or pi or something like that, then you want to be writing it as an exact value, not a rounded decimal. Okay, for the area then, the area sum is going to be 1/2 AB sine C, possibly with a rearrangement of the letters, but as long as we know that this is meant to be an SAS, we can work out the area. And that's 3 marks. Okay, moving on to 6. So this is involving 2 forces and a little bit of mechanics knowledge, but I think it's okay to just introduce it at this stage, just because it's quite a simple formula to use. So a particle P that has mass 6 kilograms moves under the action of 2 forces, F1 and F2. F1 is known, it's 8 minus 10, and F2 is unknown, it's Pi and Qj. P and Q are constants. And the capital N here is for newtons, which is what we measure forces in, if you weren't sure. Okay, the acceleration of this particle is A, which is 3 minus 2 meters per second squared, and that's our acceleration units, meters per second. Find to 1 decimal place the angle between the acceleration and I. So what I would do with this is I would draw both of these, and that gives you a diagram on which you can put this angle that goes between the 2 vectors, and you can work those out. Find the values of P and Q, that's for part B. I would use the famous mechanics formula, which is F equals ma. However, you've got to be aware that when you're writing down this left-hand side, this is referring to the sum of the forces. Okay, it's not just a single force, it's the sum or the resultant force of what's acting on your object. So you're going to need to use that. M, remember, is a scalar. A is a vector and F is going to be a vector as well. M is a scalar, and let's write that down. Okay, but it's also known because it's in the question, so you can look at that. Once you've got those values, you can then find the magnitude of the resultant force of the two R of the 2 forces, simplify it fully. And again, resultant is the sum. And once you know the value P and Q, you can work that out quite easily. Okay, final question. So this is the most complicated one, as you can probably expect from the picture, but it's ones that we've covered in previous lessons. So we've got a parallelogram, OACB, that's the whole entire shape. We've got OA given as small a, and OB given as small b. And then we've got these other 4 points, M, S, and T, dividing their respective sides of the parallelogram. They're also dividing in the ratio 1 to 4 all the way around. So OM to MB is 1 to 4, BS to SC, is 1 to 4 as well, and all, etc. all the way around. Okay, there's a slight typo in this question that you're going to need to adjust for. So the lines ST and MC intersect at the point D. So I would change this this part of the question into MC rather than change the picture. So D goes there. What I would also do is I'd put the point X somewhere in the middle here, which is where MN meets ST. So we've got that extra point to work with. Okay, to do this question then, for part A, express MN in terms of A and B. So you're going to want to use the vectors A and B which go around the edge. So I'm just going to put around the edge. There's no way of going directly across the middle because there's no vectors on that part of the picture, so go around the edge because that's got A's and B's in it. Same for part B, S to T, I want in terms of A and B as well. I do the same thing, go around the edge. Simplify your answer. Because then we can then use it to do some comparisons. And then for part C, we're showing that the lines MN and ST are bisecting one another. Now this is very similar to questions we've looked at before, and it's worth 9 marks. So it's the same setup as we've seen before. You want to do the same vector twice. I would probably suggest you do M to X in 2 separate ways. Okay, and then given that we've done parts A and B, I think they're going to be quite helpful in getting us towards proving part C as well. Okay, and then at some point, if you can do that in 2 different ways, you can then compare coefficients, as I've shown you to do. Okay, last thing then, we need to set up by saying that mx is some unknown proportion of mn. So I might write down that much. Mx is some proportion of mn. And this is currently unknown, but we're trying to show that it's half so that x is bisecting at least mn. Okay, great. Okay, that should be enough to give you a good go at number 7 there, and that takes you up to a total of 50 marks. And then if you could submit that to the Show My Homework page at the end, then I can have a look at it and give you some feedback. All right, thanks Year 12. Hopefully this video was helpful to you. And again, any more questions, let me know and I'll get back to you. All right, thanks. See you soon.